Horizontal line test, crossing a diagonal line would only cross one time. So yes, it is 1-to-1. Since we've been swapping x and y, and the identity function is where y equals x, I like to write I of x for identity. X goes in, comes out of the identity function still knowing it's x. It still knows its identity. So when you compose two inverse functions, you do one, you put x into one, take that result and put it into the other, as long as the thing was in the domain of the first one. Similarly, with reversing it, you get the identity. We're going to have reflections over the line y equals x. That's going to act as a mirror. And whatever was on the graph of the original, such as, looks like that's 0, -8 perhaps, and then 2, -1, then we should have -8, approximately. Maybe right about there in choice A. And 2, -1 would flip over to -1, 2. So I believe it's choice A. We've got another graph given. That's going to fail the horizontal line test, except for where it makes the turn in that V shape. Every other vertical line that's above the x-axis is going to cross twice. So it's not 1-to-1 because we've got some horizontal line, in fact, many, that would cross at more than 1 point. And so if the function is 1-to-1, graph its inverse. Since it's not 1-to-1, it doesn't have an inverse. We want to graph f of x equals 2x plus 4. And we're going to graph that and its inverse as solid and dashed lines, respectively. Okay. It's in slope intercept form, and so I could use the y-intercept of 0, 4, and another point, if we go up 2 and right 1, we should be at 6, 1. I'm sorry, 1, 6. Now, to back up what was being done earlier, given an equation, finding the inverse, where I replaced f of x with y, swapped x and y, and then re-isolated the y. Supposedly that would be the equation. Well, we should have, based on what I said 2 questions ago with graphs, we should just be able to swap x and y for particular coordinates that we know. 4, 0 should be on this second graph, and 4 minus 4 is 0. 0 divided by 2 is 0. 6, 1 should be on that graph. 6 minus 4 is 2. 2 over 2 is 1. So let's see if that works out. First one is a solid line. Remember to watch the coordinates that show in the upper right-hand corner. There's 0, 4. And now 1, 6. There we go. Swapping X and Y for the other graph, we want that dashed. So for 0 and 1, 6, there we go. Now, for the second line, they want that dashed. So here's 4, 0, and then 6, 1. And those should look like a reflection of each other over the line y equals x, which is the graph of the identity function. Somehow that came out as dashed. I don't know why. Now it's solid, and now it likes it. And the last one for now. We're given the promise that f of x equals -4 square root of x is a one-to-one function. We want to graph the function and then graph its inverse on the same set of axes, making that dashed. Okay, so they've given us 3 things to fill in. Square root of 0 is 0. Multiplying by -4 won't change that. Square root of 1 is 1. Multiplying by -4, we've got -4. And put it in a nice other perfect square. Square root of 4 is 2. 2 times -4 is -8. And so I'm looking for which graph has 0, 0, 1, -4, and 4, -8. And it would appear to be either A or C. We want the one that also shows its inverse. Its inverse would have to be reflected over the line y equals x. So that knocks C out of the going. It must be choice A. That's all for now. I hope it's helped. I'll see you again real soon. If it has helped, like the videos and subscribe to the channel. Thanks.